So we consider question 22 of paper 1 taken KCSE taken 2019. So question 22, the figure below represents a triangular flower garden ABC in which AB is 4 meters, AB is 4 meters, BC is 5 meters, and angle BCA is 30 degrees. Point D lies on AC such that BD is 4 meters and angle BDC is obtuse. Angle BDC is obtuse. Find correct to two decimal places angle BDC, 3 marks. The length of AD, 3 marks. The length of DC, 2 marks. The area of the flower garden ABC, 2 marks. And that's the question. Let's consider the solution. Yeah. The next question that I want us to consider is the one that has been projected on your screen. And let me draw it. This is what we had. This is what we have just seen. So it's this. And because I've extended this so much, so like this. That as such. Extend this. Should be that way. My diagram is not so good looking, but it's a sketch anyway. And use it. Think that it's a sketch. If this is bulging, it should not bulge. It should just be a straight line. It shouldn't bulge. So it does. It should just be a straight line. Wow. Yeah. So let me deal with this. Let me now do with this because we cannot waste all the time in trying to draw. Let's do with the one that I already have now. Yes. If I do that, it will look bad. But what I see is this. I have this to be A. I have this to be D. I have this to be C. I have this to be B. And I have this to be 30. Because we are given angle BAC is 30. So this is 30 degrees. Here, we also find 30 degrees. So that's what we have. Here is 4 meters. Here we have 4 meters. Here we have 5 meters. Like that. That's the diagram. So this is a straight line. This should be a straight line, just as you have seen from the question paper. So we are asked to find correct to two decimal places the angle BDC. Angle BDC. So what we want is this angle. What we want is this angle. Let's call it theta. Let's call this angle theta. Let's call that angle theta. So we want angle BDC. But then we also know that this being a triangle and we are relating dimensions or the dimensions of the sides with the angles. We can use the ratio because we would, if this is the angle we are referring to, then we would refer to this to be D. If this is capital D, this is small d. The whole of this should be small b. So the whole of that should be small b. Let me say that. Should be small b. And this is C. This is C. That is C. That is C. So I have B, C. So this is D with reference. This is D with this reference to just this triangle. With just reference to this triangle. So let me just make reference to just this triangle. So it's D, and then it means B will be this. B will then be this. With respect to just this triangle, and then C will be this. C. Like that. So I can apply the just a minute. Sorry for that. I can apply the argument that sin of theta, that is this, over this, which is 5, should be equal to sin of 30 over 4. Should be equal to sin of 30 over 4. That means if sin of this over, okay, we have sin of this over this. Now we are relating it to the bigger circle where we are saying that should be equal to the sin of this over this. Now there are two triangles here. There's this triangle and then there's the other one. So sin of this over this is equal to sin of this over this. And if you work that out, that should then tell you that this implies that sin of theta is equal to, because sin theta is a half, so sin theta will be this times this divided by 4. This times this divided by 4. So 2.5 over 4. What does that give us? Sin theta will be 2.5 over 4. So that should be about 0.625. That is sin theta. So we need to read the sin inverse of this. So it should imply that then theta, which is the sin inverse of that, will be, if you use your calculator, you should find that to be about 38.68 degrees. 38.68 degrees. But look, we are told that this angle theta is obtuse. It's an obtuse angle. So if it's an obtuse angle, then it means that we are going to get it by having to subtract this from 180. So if you subtract, so it will be, theta will be this, in which case this is acute. This is acute value, but the obtuse value of theta will be 180 degrees minus 38.68 degrees, because now it's in the second quadrant. Now we find that in the second quadrant. So if we do that, then we should get that obtuse value to be about 141.32 degrees. 141.32 degrees. So that's the angle. Now that's theta. So that is what we have here, 141.32. That's the angle that we have here. So it's obtuse. This is what we pick, because we see it's already it's greater from what we see. It's not really 90. It's not less than 90. So it's obtuse. It can't be the other one. Okay. Then, so we've already found the angle BDC. The next question is to find the length AD. The length AD. The length AD. And we are saying the length AD, if we have this, then we can get this. And this is basically this. So it means here we have 38 degrees. This is now 38.68 degrees. Yes. And this is 30. So it means we can then specify this. And specify this angle. So this angle here, let me call it X. Let me call it X. So I'll be saying that X is then 180 degrees minus minus 30 degrees plus 38.68 degrees. So that should be 180 degrees minus 68.68 degrees. If you work that out, it is 180 minus 38. So 38 plus that. So let's see. 180 minus 68. That's 12. So that is 12. So we are going to end up with 12 point. It's 12 point. So okay. If you subtract this from this, the value that you should be getting is 112.64 degrees. That's what you should be getting. 112.64 degrees. So that if you add 68 point something, it gets to 180. Okay. Then if now X, this is the value of X. If this is X, then we are then able to specify AD. We are able to specify AD by saying, can specify AD by saying it is, so we have sin of this 112.64 degrees all over AD should be equal to, what is this? Should be equal to this sin over this. Should be equal to sin of 36.68 degrees divided by 4. That's what we have. So you get the sin of this, put it here, get the sin of that, put it there. Then basically your AD will then be, 4 sin 112.64 degrees divided by sin of 36.68 degrees. That is AD. So if you work that out, you should get, about 6.25, approximately 6.25 meters, 6.25 meters. Yeah, the value is 6.25. That is because sin of 1.12.64 is about, say, sin of 112.64 is approximately 0.926. And sin of 36 point, this is approximately 0.597. So you divide and you get 6.25 meters as this, as AD. So AD is 6.25 meters. That's AD, 6.25 meters. Then the next the next thing that we do is we need to get the length of DC. Now we need this length DC, the length DC. How will we get DC? Because we know that if we can specify this angle, we put it over this, then relate it with another one. But we can relate this angle, we can find this angle. So if X was this, so this plus this plus this subtracted from 180 will give us this angle here. So let me call this angle Y, this, I call it Y. So I'll be saying that Y will then be 180 degrees minus 112.64 degrees plus, that is this, plus 38.68 degrees plus 30 degrees. And if you work that out, then you should find out that Y is about 8.68 degrees. You'll find that this, not really, no, that is not giving me Y. That is not going to give me Y. So what we have is, because the angle that I want is this, so I'll relate it to this and this, because only this gives me 180. So it will be Y is equal to 180 degrees minus 30 plus 30 degrees plus the other one we had plus this, the obtuse one, 141.32. Now, if you do this, then you should be able to get that difference to be about 8.68 degrees. 8.68 degrees. So here is 8.68 degrees. So if I want DC, then I will say that DC, okay, sin of 8.68 degrees over DC should be equal to, sin of 30 over 4. Now that is this, sin of 30 over 4. And that should imply that DC can then be found by 4 times sin of 8.68 degrees divided by sin of 30 degrees. And that should give you about, as the value of DC, to be about 5.104 meters. That's about 5.104. That's what you find as the length of DC. That's the length of DC. So that's DC, that is AD. Next, what are we asked? The area of the flower garden ABC. Now we want the area of the area ABC, the flower garden as a whole. So to get the area, we'll need to remember that the area of this should be given by, because we are relating angles to the dimensions of the sides, to sides. So it will be half AB sine theta, half AB sine theta, where AB, those are the lengths of the two sides, then sine theta should be the angle between them, that angle between those two sides. So in this case, I can take that theta to be all of this. I can take my theta to be this, all of this angle. So I'll be adding 8.68 to the x that I got to give me this angle. And I'll be using the side 4 meters and 4 meters. So that gives me half times 4 times 5 times sin sin of, add this to this, 8.68 plus x is 8.68 plus x. X we found to be 112 point something. So that is 112 point, it was 112.64 plus 8.68. So you have 2 plus 3. So I have 1 to 1.32. 1 to 1.32. So that's what I'll have here. 1 to 1 point. If you work that out, well, the value that you should be getting is approximately 9.32. Approximately 9.32 meters squared, because it's area is already 2, and this sin is expected to be less. This already 2. Yes, 2 times 10. And this sin is expected to be approaching 1. Yes, 9.32 meters squared. So that is what we have, and that is the answer to our question. So that is it for now. We meet in my next video.